Now children, in this video, we will study counting of sigma and pi bonds. How to count sigma and pi bonds. I told you in my last video also, sigma bond has independent existence, but pi does not have independent existence. Means pi is formed only once first the sigma bond is formed. So if we have single covalent bond anywhere, it will always be sigma. S for single, S for sigma, S for strong. Remember. So single covalent bond is always sigma. Wherever you have single covalent bond, count that as sigma. When we have double covalent bond, so children, the first bond will always be sigma. Then the second bond will be pi. If we have triple covalent bond anywhere between the two combining atoms, first bond will be sigma and the remaining two, whichever here are there, they will be pi bonds. So a single bond has only one sigma bond, a double bond has one sigma, one pi, and a triple bond has one sigma, two pi. That's how we count. Now suppose I have to count O double bond O, means the number of sigma and pi bonds in oxygen molecule. So children, you open the molecule with bonding. I have not written O2 like this. I cannot make out if I write O2 like this. So I have to open the molecule. I know it has got O double bond O. Then obviously first bond will be sigma, other will be pi. So it will have one sigma, one pi. Come to this ethyne molecule. I cannot write the C2H2. I have to stretch open the molecule with bonding, proper structure. So we have to have fair idea about the formation of covalent bonds. How will they form the bonds? Once I open the structure like this, ethyne, we know C triple bond C will be there and H will be here with single bond. Now counting. How many sigma and pi bonds? Obviously children, here we have single bond, here we have single bond. So one sigma here, one sigma here. Fine. 2 sigma so far. Out of this triple bond, we know the first bond or say one bond will definitely be sigma. So one sigma here, one sigma here, one sigma here. How many sigma? 3 sigma. And since it was triple, one sigma we already counted. So remaining 2 are pi bonds. I repeat, this is one sigma here, one sigma, 2 sigmas. And here out of triple, one has to be sigma as I have shown you here. So one sigma. So one sigma here, one sigma here, one sigma here. Overall 3 sigma. And the remaining 2 bonds, because the triple covalent bond will be pi bonds. Say for example, I ask you the number of sigma and pi bonds in molecule ethanol, or to which you commonly call acetaldehyde. Again, it will not be just CH3CHO. Write proper structure with bonding. I took that example only for which you have fair idea. Already you have fair idea. We write ethanol like this, CH3CHO with proper bonding. Now I have to count sigma and pi bonds here. So what will I do children? I wrote structure like this, properly open. Now it's 1 sigma, 2 sigma, 3 sigma. Repeat why? Because all single bonds are sigma bonds. So one single, second single, third single, fourth single, fifth single, 5 single. So 5 sigma bonds. Plus here we have got double bond. Out of double, one has to be sigma. So 1, 2, 3, 4 and this one 5. 5 sigmas here, and out of these two, one more sigma. So how many are here? 6 sigma. And how many pi? It was double bond, one sigma counted, so other one has to be pi bond. So this will have overall 6 sigma, 1 pi. This way children, I took some of the examples, simple examples. You can open your book and practice as much as possible. Any example you can take on your own. You can take CO2, you can take formaldehyde, you can take acetone. What all examples you want? I just took examples to show you how to count sigma and pi bond. I repeat, you have to stretch open the structure properly with bonding, then only count. Single is sigma, double is 1 sigma 1 pi, and triple is 1 sigma 2 pi. So that's how we count sigma and pi bonds. I hope it is clear to you. It is often asked. Next, what is covalency? Covalency. We have studied so far electrovalency. That was the number of electrons given or taken up by the atoms to form ions. Here, covalency. Number of electrons shared with atoms of same or other element. It is the number of electrons shared because we are studying covalency. So sharing has to be there. Number of electrons shared with atoms of same or other elements, because we know covalent bond is often formed between like atoms or two atoms having difference of En, electronegativity, as low as possible. Means it is formed between the atoms having difference of electronegativities as low as possible, right? Say almost similar electronegativities, okay? Or the best is if they have the equal electronegativities, but we can say similar. Some difference can be there, because if the large difference is there, they will form ionic bond. You have been taught this. So number of electrons shared with atoms of same or other elements. Then children, we have to see some elements like variable valency, variable covalency. Some elements show variable covalencies, like we had seen some metals were showing, some elements were showing variable electrovalency, like lead, tin, +4, +2, right? Then iron, +2, +3. Similarly here, we know that phosphorus shows valency 3 as well as 5, right? Sulfur shows valency 2 as well as 4 and sometimes 6 also. Like if I say SO2, it is 4, SO3, it is 6. How it is there, I will show it to you. Now see children, phosphorus. Atomic number 15, 1s2, 2s2, 2p6, 3s2, 3p3. So I wrote configuration ground state for the outermost shell, 3s2 and 3p. 3p3, so all will occupy 1 electron each. So here 3 electrons unpaired, so it can show covalency 3. They can be paired up and that is bond formed. So here these 3 electrons will have tendency to pair up and it will show covalency 3. It will share 3 electrons. Now, other possibility, it can get excited. Since it has got vacant d orbital, so this electron which was paired in 3s gets excited and occupies 1 orbital in 3d. So now it is, these 3 were there, this also got unpaired and this is also unpaired. So how many unpaired? 1, 3 and 1. Total 5. So in this condition, it can share with 5 electrons, right? So it can show covalency 5. It can share with 5. So it can show valency 5. We do have P2O5, we do have PCl5. So it shows covalency 5 also. While nitrogen does not show covalency 5. In case of nitrogen, we do not have NCl5. Reason? Nitrogen, being the element of period 2, does not have the vacant d orbital. Hence, there is no scope for nitrogen for further getting excited to higher d or to d orbital. Hence, N cannot show covalency of 5. We have only NCl3. We do not have NCl5. Reason, N cannot show covalency of 5 because N does not have vacant d orbital, right? N cannot show. Why cannot it show? Because you see, N is like this. N is atomic number 7. 7 means 1s2, 2s2, 2p3. All those similar, s2p3, s2p3. But because its outermost shell is second shell, so there is no D. No D. So when there is no D, it cannot get excited to D. For exciting, it has to have unpairing of electrons. So there is no further scope. Hence, N does not show the covalency of 5, although N and P belong to same group. I hope I'm clear. So N forms only NCl3 and does not form NCl5, while P forms PCl3 as well as PCl5. Because nitrogen has the vacant d orbital, it gets excited. So in short, if they ask you why N forms NCl3 only and not NCl5, while P forms PCl3 as well as PCl5, although they both belong to same group. The reason is phosphorus has vacant d orbital, being the element of third period 3s2 3p3, it gets excited and hence is able to show covalency 5. In case of nitrogen, this being an element of period 2, its outermost shell is second, it does not have d subshell, hence there's no scope for getting excited there's no scope of getting excited electron and jumping to D because there's no D. So in short, you just write because N does not have vacant d orbital while P has vacant d orbital. Hence, P is capable of showing covalency 5 while N cannot show covalency 5 because it does not have vacant d orbital. I repeat a question often asked. Why N forms only NCl3 and not NCl5? Because N does not have vacant d orbital, while P forms PCl3 and PCl5 both because P has vacant d orbital. Remember, this question is often expected. So please remember this and keep this in mind. I repeat, question. You may note down and you have to do it also. Why N forms only NCl3 and not NCl5? While P forms PCl3 and PCl5 both. Reason, N has vacant d orbital. P has vacant d orbital while N does not have vacant d orbital. Come to sulfur. Configuration, atomic number 16, it is 3s2 3p4. I'm telling you for the last one. So ground state 3s and p4, they are here. So it shows covalency 2 because only 2 electrons are unpaired. First excited state, what happens? This electron, which is double pair, which is doubly filled here, paired here, gets excited, goes to D because it has got third shell, easily excited, and now it is showing 4 because it has got now 4 unpaired electrons. So I can easily share and pair up. Second state, even this electron of 3s also gets unpaired because the vacant orbitals are there. So now it is showing 1, 3, 4 and 2, 6. Covalency 6. Similarly, chlorine 17. I'm writing for the last 3s2 3p5. So 3s ground state here and 3p5. You see 2, 2, 4, 1, 5. So it is showing only 1 because only 1 unpaired. Then first state, what happens? Out of these 2 paired, 1 gets unpaired. So now when this gets unpaired, now this is 1, 2, 3. This one got unpaired. So now this is unpaired as well as it jumped here. So 3, it is showing 3 unpaired electrons. In second state, what happens? Second state, this electron also gets unpaired. You see, these 2 were paired in the ground state. This also gets unpaired. So now it is all these 5, 1, 2, 3 and these 2 which were paired here also get unpaired, and now it is showing covalency 5. These all 5 unpaired electrons can pair up and would like to pair up. They will have tendency to get paired up and hence can show covalency 5. Third state, even this electron which is in 3s, ground state 3s paired, this also gets unpaired. So you see, in a way, all its electrons get unpaired. Total, all 7 got unpaired and they all can pair up and hence it can show covalency 7. So children, they are just expanding their, they are getting excited and reaching to subshell D. It was only possible because they had vacant D orbital. This scope is not there with fluorine. Although F and Cl both belong to same group. They both are halogens, elements of group 17. They all have 7 electrons in the outermost shell, similar configuration, ns2, np5, ns2, np5, 3s2, 3p5. But F being the element of period 2, means second shell, outermost shell, will not have vacant d orbital, hence cannot cannot have the excitation of the electrons, and hence cannot show these variable covalencies. F shows only one covalency, and that is always 1. So F always shows 1 because out of its electrons here, these two are paired, these two are paired. It's only one electron unpaired in case of F. You can try it. F, I'm writing here. F is what? Atomic number 9. 9 means 1s2, 2s2, 2p5. So you see, second shell, there's no scope for D, hence F cannot show variable covalency, while Cl shows variable covalencies of 1, 3, 5 and 7. So children, this is all for today. I hope you have understood how to count sigma and pi bonds, and I hope what is covalency and how and why they show variable covalencies. It was just because they had vacant d orbitals. Again, repeating for the last time, out of n and p, n forms only NCl3, while p forms PCl3 and PCl5 both, because p has got vacant d orbital. You have said everything. Similarly, F and Cl, they both belong to same group, but F does not show variable covalency while Cl shows. It is just because Cl has got vacant d orbital. You don't have to draw everything. If it is for 2 marks or higher, then only you will draw. Otherwise, just 1 mark you can write because Cl has got vacant d orbital. Sulfur here, oxygen again does not show variable covalency because oxygen, sulfur, they both belong to same group. But oxygen cannot show, sulfur shows, because again oxygen means, you see, oxygen, I'm writing here, oxygen means 8. 8 means 1s2, 2s2, 2p4. Again you see, second shell, there's no p, there's no d, hence it can also not show variable covalency. So why they show, why they don't show, I hope it is clear. So this is all for this video, as well as I hope all for today. Something very important and totally new for you. Rather children, from now onwards, what all will be taught to you will be totally new for you. Ionic and covalent were known to you, but this is now gradually things will be totally new for you. So see videos attentively twice, thrice whenever you have time, and update your notes, complete your notes on the regular basis. Thank you children. This is all for today.